Hello students, this is going to be part 2 of the Unit 7 review. So we just did 1 through 6, which was the front of this page in part 1. So in part 2 we will start here on the back at problem number 7. They want us to write this expression in radical form. So radical means I need a radical sign. Whatever is in parentheses here, this is going to go underneath the radical. This tells me my exponent. This tells me my index, and then I have rewritten the expression from rational exponent form to radical form. Okay, here we have a word problem dealing with the formula for the volume of a cone, and they tell us what the radius is, so they tell us what r is, and they tell us what the height is, and they want us to find the volume. So first thing we're going to do is substitute. R is being squared, so we replace R with the 6xy to the third, and our h, we're going to substitute in the 2. Now we simplify. So we have v equals 1/3 pi. So we're going to take 6 and raise it to the second power, x and raise it to the second power, y to the third, raise that to the second power, and then we have this 2 out here. So I can take 1/3 times 6 squared times 2. If we do that into, put that in your calculator to just do that very quickly, we're going to end up with 24 pi. Then we have x to the second power, and then 3 times 2, because we have power to a power here, gives us an exponent of 6 for the y. So we end up with 24 pi x squared y to the 6th. Problem number 9, they want us to evaluate this expression, or I'm sorry, they want us to basically simplify this expression. So again, here we have a product being raised to a power, so each of these is going to have to be raised to the third power. Then in the denominator, we have a product being raised to the 0 power. Since this is a 0 power, we know that this whole denominator is 1, so the only thing I really need to deal with is the numerator. So I'm going to take 3, raise it to the third power, x to the 0 gets raised to the third, y squared gets raised to the third. So 3 to the third power is 27. 0 times 3 is 0, and anything to the 0 power is 1, so this just becomes 1. And here we have y squared to the third power, so 2 times 3 is 6. So this all simplified to just be 27 y to the 6th power. In problem number 10, we have a triangle. We have these 3 sides, and we'll go ahead and put these in parentheses to help you see these sides. And basically they're all going to be added together. So we have 5a squared minus 4 plus a squared minus 2a plus 12. So first side plus second side plus our final side, or the third side, which is 2a squared minus 6a plus 8. So our a squared terms, we have 5 plus 1 plus 4, which gives us 10a squared. For our a terms, we have negative 2a and negative 6a, so we get negative 8a. Finally, we have our constant terms. Negative 4 plus 12 gives us positive 8, plus another 8 gives us 16. So we take the 3 sides of our triangle, add them up, and this is going to be the perimeter of the triangle. In problem number 11, they want us to simplify. So here we have a product being raised to a power, and here we have a power being raised to a power. So just like before, even though this is a fraction, we still do it the same way. We take the 4, raise it to the 1/2. Take the squared, x squared, raise it to the 1/2. Take the y to the 4th, raise it to the 1/2. And then this one, I can go ahead and multiply. What is negative 2 times negative 3 over 2? That ends up to be just 3. because negative times negative is positive, and these 2's will cancel, leaving y to the third power. Remember that 4 to the 1/2 is really the square root of 4. The square root of 4 is simply 2. Or you can take and type this into your calculator, 4 raised to the 1/2 power, you should get a 2 back. Here we have a power raised to a power. 2 times 1/2 is 1, so we get an x. And then 4 times 1/2 is 2, so we get y squared, and then we had our y to the third. Well, we still have some like bases here, so we have one more step. So we have 2 times x, and then we have like bases, so we're going to add their exponents here. So the exponent on the y becomes 5. For problem number 12, we have the area of a rectangle, and we have its length, and they want us to tell the width. We know that length times width equals area, so if I take the area and I divide it by the length, I'm going to get the width. So I take my total divided by one of the parts, I get the other part. So we just simply apply our quotient rules. So 18 divided by 3 is 6. Because we're dividing like bases, we're going to subtract their exponents. 4 minus 3 is 1, so we just have 1a. And then 7 minus 4 is 3, so we have b to the third power. Okay, our final problem on the review, number 13, they want to know what expression is equivalent to all of this. So I would take 14, negative 3, and 2/7 and go ahead and put those in the calculator. And what I would get there is a negative 12. And then start looking at my like bases. I have a to the negative 5, a squared. So negative 5 plus 2 is negative 3. Then I'm going to look at all the b's. So I have negative 1 plus 5 is positive 4. Positive 4 minus 3 is 1. So I just have a b. But I can't have a negative exponent. So I'm going to put the negative 12 in the b in the numerator, and this negative exponent tells me to put a to the positive 3 in the denominator. And that is our final question on the Unit 7 review. And so, once again, there are all those answers in case you needed to see any of those again. Push pause if you need to. Then again on the front.